Welcome back. We're continuing our series on preference heterogeneity in discrete choice models. And in this video, we're going to talk about finite mixture models. These contrast with what we talked about in the previous video, which was random coefficients that are assumed to come from a continuous distribution. With finite mixture models, we're assuming that the unobservable preference heterogeneity comes from a discrete distribution, and this has some advantages in simplifying the computation so that we don't always need the integrals or the quadrature or the Monte Carlo integration that we introduced in the last video. As you can see on the screen here, finite mixture models provide an alternative to mixed logit models. And basically, we're assuming that instead of having a continuous distribution for the mixing distribution is instead discrete, meaning that it has finite support, and then we're also assuming that it's independent of the other variables. We're going to call the mixing probabilities, or the type probabilities, pi s. So this is just the probability of someone in the population belonging to the S group. And then our log likelihood in this case is going to integrate over these unobserved groups, but it's not going to have an integral, it's going to have a summation instead because we are dealing with a discrete distribution. So there's only some finite set of mass points in our distribution, so we can sum over those mass points, multiply by the probability mass, and then we just have the same thing as before with the mixed logit. So our likelihood function looks a lot simpler because there's no integral and there's no mixing density that we have to deal with. As with other preference heterogeneity frameworks, we're going to need panel data to identify this finite mixture model. So we assume that the gamma, that is the parameter that has the unobserved preference heterogeneity, we're going to assume that that's stable over time, as we talked about in the prior video on identification. And then with panel data, we're going to introduce a dimension of t into our model. So everything is now subscripted with t. We have a double product over t and j. And again, because the epsilon ijt's are iid over person, choice alternative, and time period, then that's what's giving us this logit probability formula for this part of the likelihood. And then again, we're just summing over the different groups that our preference heterogeneity distribution comes from, and then we're multiplying by the mass probabilities. So we can compare this finite mixture likelihood with the one from the mixed logit with panel data. And basically, you can see the resemblance between the two. The main difference is that this f of gamma times d gamma has just become this pi s, and then this integral here has become a summation over s. So again, because we have a discrete or a finite support distribution, then we can use a summation instead of an integral. That is a brief introduction to finite mixture models. In the next video, we'll talk about something called dynamic selection, and this is a particular broad class of problems that finite mixture models can help solve, and this will allow us to take the tools that we're learning about preference heterogeneity and actually apply them much more broadly than just discrete choice models. So we'll talk about that in the next video, and I hope to see you there.